Hello there, our wonderful and esteemed viewers on this favorite mathematics YouTube channel, Mathematics by Abu Zainab. That special channel created for you and I to come together to demystify mathematics and tackle the age-long phobia associated with this all-important subject, one topic at a time. I wish to appreciate you sincerely for staying tuned and staying subscribed to us. Thanks and God bless. Today's class is going to be a continuation of the last video, which is on probability distribution and particularly binomial probability distribution. In the last video, we looked at the case of finding the probability distribution of a particular binomial, and whereby we had to find the respective probabilities of the separate possibilities from 0 to 5. Today we take it a notch higher to look at another classic example of questions, exam questions on probability distribution. So on the board I have the probability that an athlete wins a race is 0.8. That's a given. So that means P, small p, is 0.8. Now in 6 different races, automatically that's n is 6. What is the probability that he wins? Then look at each of the following respectively. 1, all races. So here we're going to say that we are required to find probability of x equals to 6 all the races. 6 in all. So we're going to simply use the formula. Remember that probability of x is equals to x equals to n combination x p raised power x 1 minus p raised power n minus x. So in this case, we're going to have 6 combination 6, then 0.8 raised power 6, then 0.2 raised power 0. So simply put, just substitute the values n to be 6, x to be 6 in this particular case, and p to be 0.8. And once p is 0.8, 1 minus p is going to be 0.2. So when that is done and you compute, you're going to have 0.2621444. That's the probability that all the races are won by the athlete. We move on to 2. Probability that no race was won. No race means 0. X is 0. No race. So again, we replace our x with 0. Every other thing remains as 1. So we are going to have 0 here, 0.2 raised power 6. That's 6 minus 0. So when you compute this, you're going to have 0.000064. That's the probability that no race was won by the athlete. Then C, probability that exactly half of the races are won. Exactly half of what? The total races are 6. So half of 6 is 3. So in this case, we're going to have 6 combination 3. Then 0.8 to the power of 3 and 0.2 also to the power of 3, which is 6 minus 3. So when you compute that in your calculator, you're going to have 0.08192. That's the value for exactly half of the race. Then D, we are told the probability that he wins at most 2 races. Okay, at most 2 races, that means you have x is equals to 0, 1, and 2. That's at most. At most means the maximum is 2. So that means from 2 and below. And below means 2, 1, 0. So in this case, we're going to compute for probability that x is 0 plus probability that x is 1 plus probability that x is 2. We're going to compute these respective probabilities and add up, and that gives us probability of at most 2. So here we're going to have 6 combination 0, then 0.8 raised power 0, then 0.2 raised power 6. That is for 0 plus 6 combination 1, 0.8 to the power of 1, 0.2 to the power of 5. Then lastly, 6 combination 2, 0.8 to the power of 2, and 0.2 to the power of 4. So we're going to compute each of these respective probabilities, and then we have, so in doing so, we're going to have 0.011696 as the probability that is required. So that leaves us with the last question, E. So for question E, we are required to get the probability of at least 1. At least 1 means 1 and above. So that means X is 1, 2, 3, 4, 5, and 6. That's at least 1 and above. Now this is going to be cumbersome and quite tedious to compute for each of them. However, you recall that probability of a sample space is 1 in its entirety. So the only missing value here is 0. So using the concept of probability of sample space being 1, we can easily say this probability is equivalent to 1 minus probability of x equals to 0. Since 0 is the only missing value here. So in other words, once we get probability of 0, take it away from the entire 1, and that gives us everything here. Hence we have a probability of 1 minus, this is actually 6 combination 0, 0.8 to the power of 0, and 0.2 to the power of 6. Once you have done that computation, you're going to have 0.999936 as our answer. So that essentially is how to go about it. It won't really make sense to do the entire job of computing 1, 2, 3, 4, but if actually you do, you're going to get the same answer. But why go that route when it's an easier approach? And with that, we come to the end of the solution of the probability distribution question. And by and large, we've come to the end of probability distribution in binomial category. I believe you enjoyed this class and found it a lot interesting and fun, much as I did. If you do, please don't forget to subscribe, like, share, and importantly, turn on your button so that you'll be the first to know when I shall drop our next video. And the next video is going to be on the other discrete probability distribution, which is Poisson. Looking forward to seeing you there. Stay tuned and God bless.